Okay. Now we are back into topic what? Topic 5, which is the geometric skills and constructions. Okay. Now, as usual, we would want to find out whether students are very, very attentive by posing a sample question. Now I will pose like two questions, but one is a calculation, just a check-up. 2 times 6 gives 12. What of the 4 times 6? 24. And then 7 times 6? 40? 42. Then 8 times 6? 48. 9 times 6? 54. 54, not so? What of if we had is 2 for 6 times 6? 36. I'm also going to put 11 here. 32 times 11? 92. 63 times 11? 693. 54 times 11? 94. Now look here. 33 times 11, who can give the answer without a calculator? By looking at this.
390.
Without a calculator, look at this.
393.
No? No.
363.
That's you put the calculator down, not so mentally. Okay, let me give you without a calculator, not so. 44 times 11, I'm getting 484. 32 times 11, I'm getting 352.
Teacher, I think you have to get the second number in 5.
I think now that's small trick, that's all. Is it correct? That means you can multiply any 2-digit number by 11 quite easily. Write out, add the 2. Next time we shall give you another one in the next topic. But answer this question to check whether your brain didn't get berserk. Are you ready? Last year was 2020, not so?
Yes.
When 2021, what was the name of Kampala, which is the capital city of Uganda last year? Yes? It was Kampala. Thank you very much. You were not confused. I've seen the heads are now attentive. Okay, now let us go to our topic. That means that I will also push you to go and get for me a few math tricks of your own choice, and you come and it means I will task you every lesson you present a math trick or math skill or a tricky question. Okay? Simple logic. Now, topic 5 is called what? Geometric skills and construction. Now, under that topic, we have the subtopics. We have the first subtopic as constructing perpendicular, bisectors, midpoint, yeah. Then constructing parallel lines, yeah. Constructing circles and arcs. Maybe before that, constructing just angle bisectors, then constructing circles and arcs, then constructing. These are now all construction skills. See that? Constructing angles, those are very many. Then constructing polygons, inscribing and circumscribing. Those are all skills. Then we shall discuss the concept of the locus. These are construction skills. You see, there are very, very many, but then part B we shall have it under the locus. Now, we start right away with constructing perpendicular bisector. Yeah. Now, that is constructing perpendicular bisectors. I think I will make sure one of my sides here is quite sufficient for me, and I'll use it basically that side for every skill that I want to check. Constructing perpendicular bisectors. Now, we shall start with point 1, constructing a perpendicular onto constructing a perpendicular hold that before that. What's a bisector first? To bisect in English is to divide into equal or different parts. Therefore, perpendicular means did you know that to be perpendicular is to be normal? To be normal in English is not to be abnormal, not so. Now, to be normal in math is to be exactly at an angle. We said that the line is normal to the other, or a normal of the other. Yeah. Then a perpendicular bisector is just a what? A line that is normal but divides the other line into two. Answer? Yeah. Okay. How do we construct a perpendicular bisector onto a line? Okay. A perpendicular bisector onto a line. You want to demonstrate that?
No, I just want to
Explain. Okay, explain as me. I put a what? As me, I put the concept here. Yes. How do you construct a perpendicular bisector onto AB?
I'm going to explain one that is not with a given point above the line. So like line AB, you'll have to use those points and create arcs up and down.
Arcs up and down.
So that you can join them and form a perpendicular
Bisector. Okay. Okay. That what you do is you stand at each edge, since you want to divide into two, then construct an arc up and don't adjust the radius. That means maintain a fixed hand. Then you turn here, do the same, not so, and do the same, because my instrument wants to move. It's flexible, but if we tie it tightly, tight so that it's fixed. You said we stand at each point, but we adjust the compass so that it's beyond halfway at least, not so? We have an arc up and an arc down, then turn to the other side, also maintain an arc up and an arc down. You will have constructed a perpendicular bisector. But it's neat to do it in a graph paper, because it makes we don't say drawing on a plain paper is bad, but it avoids bending lines. Now this one is a perpendicular because it has divided it into two at an angle of 90. Now before we leave that concept, I wanted to also now, that's finished. I'm on part B, but I will not rub that. Locating midpoint of a line. Locating midpoint of a line. But if you wanted to locate the middle of any line, like if you are given a line segment, we say the segment means a line that has a starting point and has an ending point. If you wanted to locate the midpoint of this, how do we achieve that? Yes, Grace?
It's just like asking to find the perpendicular bisector of the line segment.
Exactly. It means the difference is that we make it dotted, since you are not interested in the what? We are not interested in the bisector, but we are interested in the middle what? The middle point. Therefore, you make the bisector dotted to locate the middle point. Therefore, this is the middle point. We can measure its length using a ruler and know the distance on every side. Yeah, that's pretty good. Now we want to again go to part C. That is constructing a perpendicular line onto a given line through a point. Now that assuming our line is maintained there, but we wanted to draw a perpendicular from there to meet that line, not necessarily bisect equally, but we can have it just meeting it at an angle of 90. How do we achieve that? How do we draw a perpendicular? Construct a perpendicular onto AB from P. Construct a perpendicular onto AB from P. Yes, I see Grace. Why not Precious? Okay, Grace, how do we achieve that? How do we draw a perpendicular onto this from P?
You have to place your compass needle at point P.
We have to place our compass
Create arcs on line segment
and create arcs here on line segment here and here, not so? Then we use these arcs to create the downer arcs. Not so? Yeah. Sorry, to create the downer arc, it wants to disappear. Okay. Then it means that's it, not so? Now what do we do?
You have to join point P to that segment of those two arcs that are coming down.
Yeah, we join through here. It's a perpendicular, not necessarily a bisector, not so? It has created 90, but not in the middle, but it has met at 90. That's another concept. Now the other one, how do you construct a perpendicular through a point on the line? Constructing a perpendicular line through a point on the line. Perpendicular through a point on the line. How do we achieve that? Yes, Precious, you have to explain that. Through a point on the line, assuming we have our marked point there.
You put the needle of your compass at that point on the line.
You put the needle, yes, the needle where?
At that point.
At this point?
And you draw arcs on that same line.
On this same line I draw arcs?
Yes, that side and also this other side.
And this other side.
Yes.
Then?
And then you construct You put the point
here,
no?
here,
Yes. And you draw
an arc and an arc.
and the same this side.
The same this side, and we draw an arc and an arc. Then we draw a perpendicular line to. Then we draw a perpendicular line, not so? Yeah, that's pretty good. Not so? That is okay. That's very smart. Oh, those are perpendiculars. Then I want to discuss how do we draw parallel lines. How do we construct parallel, a line parallel to another line? Okay, constructing the parallel lines. How do we achieve that? If I have one line and I wanted a line parallel to it, I have a line here, then I wanted another line constructing the parallel line. That means construct a parallel line 2 centimeters from another line. How do I achieve that? Yes, Grace, you seem to have an answer. Yes.
So you'll have to create points on that line segment.
I'll have to create points on this.
Yes.
How?
So I'll create any points of any length.
Any length.
Yes.
And I can create like this. Like that.
Yes.
Okay.
Then you use those points created.
But I want 2 centimeters away.
You have to measure the 2 centimeters.
2 centimeters on the ruler. You have to take down 2 centimeters on your ruler, not so? Now mine here, that's 95, that's 10 centimeters. My 2 centimeters would be around, this is 1, this is 2. Not so? Mine would look a bit more smaller, but you can use yours, not so? You measure 2 centimeters, then you make sure the width, the radius is 2 centimeters. What do we do?
You create arcs up, but those arcs should be the same distance, 2 centimeters.
2 centimeters, like this. Eh?
Yes.
Okay.
Then you will get your ruler.
My ruler.
Base at the top of those 2 arcs and create a line.
On the top of the tops. That means you come on their tops, create a parallel line. That's good. That's great. Now that's finished. Now the next part is constructing angle by bisectors. And we are on skills. How people are learning, not so? Yeah. Constructing now angle by bisectors. Yeah. Like if I gave you if I gave you two an angle already made by 2 lines, how do we bisect? To bisect is to divide into 2 That means how would we divide this angle into two parts? Yes.
You have to create arcs.
You'll have to create
Arcs.
arcs. How?
The center.
You'll have to stand where?
At that center point.
At this point.
Create arcs on both lines.
On both lines.
Then use those arcs to create other arcs that will unite, and then you divide the angle.
You divide the angle like I've divided. Okay. Okay. Then you draw a what?
Straight line.
Now we have to, upon learning here on angle bisectors, we must also learn how to measure those angles. Are we able to measure those angles themselves? How do we achieve it? How do we measure now this angle? Call this one to OA, BC. How do we measure the angle there?
Use a protractor.
A protractor. And it would ensure, yours is transparent, you ensure this middle. I hope you are there. Mine has a hole to see through, but ensure this middle is here and this line lies along this line. Not so? Which scale do we use?
108.
Now, you see the scale which has, where the protractor is lining with the line is the 0. Did you hear that?
Yes.
This is the, where this line is the 0. You can't use it. Use this line lies on the 0 of the protractor. That means use the inner what? The inner scale and count going this way. That's around 30. Mine is around 30 degrees. Not 30, this is 30, then this is 32. We don't have points on the calculator, therefore I have 32 degrees. That's angle A or B. That means angle A or 32 degrees. Then angle OBC, COB rather, again here. That's around, this is 10, 18, is it 7, 18, 16. Angle COB is 16. Clear? Okay. Now I wanted it to tilt a shape for you to get for me an angle bisector and also measure for me the angle with respect to sides. How do we measure that and how do we get we want an angle bisector of this and also measure the angle. How do we bisect that? We use the middle point again. That means you'll use here and what do you do?
You create arcs on line.
This one and this one also. Then you stand here. You can either extend the radius or leave it. Not so? Then me I will require, but it's good to extend to avoid it being very, very close. Okay, then I'll require that you again measure that angle also. You measure that angle. Are you right away? You're here, not so? Yeah. Measure for me the whole angle PO to this. On yours, angle POQ is what? Then you also measure for me, can call this SOQ. How shall we measure this angle? Again, you see the protractor this line must lie along. Then this middle must be there. Not so? Then we say where if you lie on this line it becomes 0, 0. Then you have to count the inner scale which are 0. That means you are ending on 140, mine is around 140. I have to extend this line to be visible. The line to be visible. Yeah. Now I think you've seen this is what's this angle? This angle is around 140, 143, 142, 142. Not so? So if you have many scales, you can even measure using the 0 on this one. I hope somebody now sees. If you wanted to use this line as your 0 to be the same, you now put this to be 0. But this time I made this, I just keep playing with the protractor. You can make this 0. And now when this is 0, you will use the outer scale. It will end on the same value, 140 something there. Yeah. Now I've left out that. That means you can now bisect and even. Now let us go to constructing circles. Now what is true with the circle? Maybe that skill needs to be also understood by a student. What's a circle? Maybe to just check about a circle here. Let me just use a rough sketch of a circle here. Now a circle has a center, of course. So then from the center to the this is called the circumference, the distance around the circle. This distance is called the what? The radius. And from one side to another is called the diameter. And you must be passing through the what? The radius. The center rather. Now, there is another line that can pass anywhere than the radius. What is that? That means we are constructing circles, and we must first look at parts of the circle, then parts of a circle. We have, what's that? Chord. Then the region created here is called a segment. There is what we call segment, smaller segment, and there is a downer part called major segment, minor segment, but we can just leave it at segment. Diameter is distance from one side to another through the what? Through the center. Now you can have two radii. When you have another radius and another radius, what is this region called? AB here is called, and there is this side is called what? This is a sector, is a region bounded by two arcs. Then this is called an arc. Okay. Now that means I'm shifting very fast. How can we construct a circle of radius? Construct activities, construct a circle, construct a circle of radius 4 centimeters. Not so? That one, it means you just measure how many centimeters? 4. Then you stand at one point and construct, not so? Measure 4 centimeters on your ruler, then construct a circle and label it for label it from that point where you constructed. Call it forward 4 centimeters. That's finished. Now, if they give you a diameter, you have to, how do you get the radius in case you are given diameter? You divide by 2. Okay. Now constructing arcs. Of a circle of radius 4 centimeters and angle 45. Of course, there we shall just pick a little on that angle and construct it, but knowing very well that we are now going to start constructing what? Angles. Now right there we can demonstrate 45 first, then we shall ensure that the radius is what? Is 4 centi. How do we construct 45 before even reaching construction of angles? Yes. Can you use this device and construct? Okay, 45. How do I achieve that? Let me first put my line there. But in case you are given an angle that you can't construct, then you have to use the protractor. That's so. Now, since you are interested in you are interested in an arc and not the angle, every line must be what? Yes. Now, how will I make 45? What will I do? Yes, precious.
You first construct degrees.
I'll first construct 90. That means how?
You'll select a point in the middle of the line, and then you put the needle of your compass there, and then you draw arcs on it.
Let's assume that you wanted me to go in the middle, not so? Remember, I need 4 centimeters of this. That's all. Ensure that you have drawn a line of 4 centimeters first. Those are. Make sure this is 4. Measure with the what? I want to construct it here. How would I do that? Yes. Grace, what I do?
I think you have to first use the points, the end points of that line on 4 centimeters.
Yes.
And then you grade axe up.
Axe up?
Yeah.
Up like this?
No. They have to join, so you should adjust your plan.
Yes.
So that those, the axe that you'll have formed from those 2 points will meet at a certain point.
You are hiding the answer. It's like you're explaining to me a route which is to cross a bridge which has no bridge. A river which has no bridge. Let me give a starting point. Assuming you constructed here a uniform. You should have many skills now there. I'm cutting here. And I cut here. Can't I use this to have 90? Not so? Do you believe that? Then that should be dotted. Grace, have you seen that skills must be many depending on the problem? Now this must be dotted because you are not interested in it, not so? Not interested in it, yeah. Now you see. Now at that point you divide 90 into 2, not so? How do you achieve that division?
Down.
Here.
Yes.
And I'm bisecting the 90 and this one. Then that is the 40. I mean that's the 45. But remember, I must have an arc of how many centimeters? 4 centimeters. Now you'll have to have that, and these are dotted because we are not interested in the angle but in the arc. Then sorry, you now ensure your 4 centimeters were here, not so? Were here. Now you complete your arc here. That's the arc. I hope you see those skills. That means you extend this to be, then this is 45 degrees. Clear? We are now very far. We are now going to constructing angles. We are there constructing angles. Now we start. Can you manage it and we construct all on the same? But you can construct as you isolate according to where you need it to be. Constructing angles, we have 15, 30, 60, 120, 45, 90, 135, 70, 5, 105, 22 and a half, 37 and a half, 165, 180. Yeah. Can I put them on the same thing all at once? But you know that some angles, if you construct 30, subtraction from 180 gives us these big angles are just you construct a small one, then behind will be a big what? Angle. We construct all on the same. Yes, that means I'm going to construct all of them. Now those that you see, 15 is a half of 30. Then 22 and a half is a half of? Is a half of? 45. Then this one is a half of? 37 and a half multiplied by 2, you get? 75, yeah. Now you can construct. Let us start. I'm going to have a point somewhere. 180 is just drawing a complete what? A semicircle, and I'll have received 180 already. And that means 180. Label. Whichever you construct, you do what? Label. Now, the next one, I'm just going now to divide here and get 60. You know, when you stand here, you get 60. Did you know that?
Yes.
The 60 is already got. Okay, 60 is good. Now we label it. We are supposed to label inside, but because I'm adding many angles, I'll just label on the line. The next one, which angle is automatic? 30. I bisect.
No, 120.
120 how? This one is 120.
Yes.
If you want it this side, you would make an arc where? Then this would be 120 this side. That means 120 is this way. Okay? Oh, we label it here as 120. Oh, you have that in mind, no, not so? Now, which angle is this? Which angle is that? 90, not so? Okay. 90. Now, 90. If that is 90, how do I get, which other angle can I add there? We are adding 40. I first add 30, how? I bisect this one. I've got which angle? 30. How will I get 45? Bisect 90. That means I've got this one as what? You're saying this one is 30. Sorry. Then 45. How do I achieve 45? I stand where? I stand here to divide this 90. Not so. I also make 15, not so? Here. On the other side of 15 you get, behind 15 you get,
You get
180 minus 15.
180 minus 15.
That means behind
Get 100.
60, 65. That means when you get 15, you can get 165. This is 15. This one is 45. Huh? Okay. 45. What other angle can I get? This is 90.
75.
75. It is between the 90 and the 30. What's the angle there?
90 and
30. What's the difference?
65.
90 and 60. What's the difference? 75. It means when I divide this into 2, I get 15. Plus 6, I get 75. That means standing here, I'll be getting 70 what? 75. I don't know whether you notice that I can get as many angles as possible. If you divided, you see between here there is 30. It's 90 minus 6 is 30 divided by 2, 15 plus 60, 75. Now what if you wanted an angle between 90 and here? 90 minus this 45. Also, divide by 2, 22 and a half plus 45, 67 and a half. That means you can also construct what?
67.
By standing between
90 and 45.
I don't know whether you notice that. It means I can even have another angle 67 and a half by standing here and here. It means you can keep even knowing even other angles which you might not think about by just dividing. This is 75. This is 67 and a half. There are so many students which we can get here. That means if I wanted the 37 and a half, I just divide 75. Do you know we can accumulate so many? Now we shall not continue with angles because we can construct as many as possible. If you want 120, you just label behind of 60. From here is 120. And a big angle, you label behind the other small ones. And the students have a mistake. They say construct 120. He constructs 60 and labels the small angle as what? 120. Now, all these you can keep just dividing. You stand on where you keep dividing. Now we shall right away go to constructing the polygons. And there are many polygons, and we shall start with a square, rectangle, rhombus, parallelogram. Square. We know that a square has all sides. Construct a square of 4 centimeters. Then rectangle. construct a rectangle of width 4 centimeters and length 6 centimeters. That means because they have kind of 90, that means I expect you to construct an angle of 90 at the start. You are first going to draw a line of forward 4 centimeters. Line of 4 centimeters. Make sure you have measured 4 centimeters accurately. Then construct 90 at the start only. At the start, construct 90 at the start only. That means it's easier to make 90 without bothering. Hope you have made 90. Make sure you measure 4 centimeters after that. Here 90, your 90 is here. Then measure 4 centimeters. Hope the 4 centimeters has been measured right. Make an arc, then make an arc, then make an arc. Is that finished? Then it means get your ruler, join to that point, join to that point. Those are 4 centimeters everywhere. Don't rub those arcs because we need to see them that you constructed. Now we want to go to a rectangle. I hope a rectangle can be done in a similar way. Do you have any problem with the rectangle? Can be done in a similar way. You start with 90 at only 1 point, not so? Now we can drop to a rhombus. A rhombus. And we drop to a rhombus. What is the features of a rhombus? Outside circle. Rhombus, construct a rhombus ABCD with AB equal to 6 centimeters and angle B AD equal to 60. That means we start with the angle only once. Construct the angle once. That means we need to have a length of 6 measured accurately. 6 measured accurately. Make sure you measure 6 my ruler is a bit distracting. That's why I'm just using illustrations. You measure 6 accurately. Then now you construct which angle? 60. Yes, 60 degrees. 60 degrees. Yeah, is that constructed? Only once is enough, no need to construct at the other side. Then after that we have it 60. Have it 60 here. Now you measure 6 centi because the rhombus has all sides what? Now you measure 6. Not so? Hope it will fit my. Let me reduce my 6, hoping that your 6 is accurately measured. Not so? Let me reduce my 6. Ensure that it is 6. Then have it there. Not so? And transfer just the same, and transfer just here. That's done. Precious. Have you got it correct?
Yes, but the space.
The space is more like it was for mine, but for you, don't reduce your compass. Don't assume. Now this is 6, and this is also 6. And this angle of ours is 60, 6 centimeters, A, B, C, and D. Somebody complained. Is that fine? What if you ask you a parallelogram, AB 6 and BC is 4? Change this question to a parallelogram. How do we achieve that? The same method? The measurements will change for this. Will go to 4, and also here you'll make at 4. Then here we will have to pull to 6. Okay, and you'll have to join it. That will be a parallelogram. Okay, we can't speak many things. I'm going to a triangle now. Yeah, let us construct triangles. A triangle. Are we right there?
Yes.
Now, triangle, there are many cases. Triangle ABC, given AB 6 centimeters, BC is 4 centimeters, and AC is 5 centimeters. I hope that's clear. You see, we can give all sides, or we might give one angle construct a triangle, a PQR with the angle PQR equal to 135 degrees and PQ equal to 7 centimeters. You see that one, we have given you one angle. Is it pretty easy? I start with but it's wise to have a small sketch, not so? And you locate sketch, you locate A, B and C, knowing that AB is 6, BC is 4, AC is 5, not so? That means we just keep measuring the length, see? Have you measured your 6 AB already? This is 6. Then, each length you have to measure, not so? Now you measure 5. You measure 5 and I hope I've already measured my 5. On my device 5, not so. The other side you measure how many? 4. Go to your ruler, measure 4. That means you have this as, this is 5, you measured. The arcs, don't rub them. They show that you have done work. This is 4, and this is 5. That's settled, not so? Now, let me answer part B from here. We have to first construct an angle of 130. PQ is this and the PQ and QR is 5 centimeters. Construct. Now that 135 is one of the best angles, meaning the P and the Q. PQ is already given. That means ensure Q is the best angle. This length is how long? 7, not so? This is P. The angle given is on what? Is angle, the middle angle. Construct 135 here. 135, its smaller angle is 45. And since 135 must be, is a big, the small one must be the other side. That means I have to construct as usual. But you have to prolong that line. First, you have to prolong that line to ensure that the angle fits. Prolong it with dotted words. Dotted lines is not part of your diagram, your work up to there. Now, you have now to come and divide to get 90 first, but we're not interested in 90. Not interested in 90. That's now your 90. You're not interested in it. You make it dotted. Make it dotted. Then divide 90 to get 40. 45 this side, so that 135 is inside as the question wants. Now you make here your 130. This is 45. Make it full because you need it one. This is one. Now 135 is this way. Not so. And you need to measure 5 centimeters. That means measure 5 centimeters and go on your ruler, measure 5 and get the arc for 5 centimeters. Now you close down the triangle and this is Q, this is 5. Now, if you are required to measure this angle, how would you measure this angle? If I want this length and this angle here, how do we measure the length? Some of you like transferring the ruler up to here. That's not good. It's good to locate using the tip of your set divider. The use of the divider is to locate that. May I have my construction, but you get a divider. Set divider, I think you know it. Stand here, pull that length using a divider. Take it to your ruler to be more accurate. Yeah. Some of you have never used the divider since you wrote your set. How do we measure this angle? If we wanted you to measure that angle in the corner, angle PQ, no, this is R, sorry, PRQ. How do we measure angle PRQ? That means you make sure the protractor's line sits on one line. Either if you make it here, then this line will act as 0. That means make sure this line lies along this line, then 0, you use the inner scale, you read up to here. Yeah, that one you did from there to be around, I don't know yours is what, but you read the inner scale.
Mine is 26.
26. If you wanted it the other way, you could now make it to lie on this line, and this one becomes 0, and you read the where is it? Yeah. Then you outer scale, yes, outer scale. Hope that's clear. Now let us go to inscribing and circumscribing. And we shall just demonstrate using a already drawn triangle. You will find many triangles and you construct them. Now, Using already a drawn triangle, now we are discussing what we call inscribing, is to put a circle where? Inside. Now I'm going to use already a drawn triangle here. How do we put a triangle inside this one? Inside. Then I'll use another sketch, demonstrate circumscribing. Okay, let us finish up with that. How do we draw a circle inside? We have to construct angle by bisectors, not so? Bisect. Have it there. Let me adjust so that I'm a bit inside. Not so? Then do the same for this corner. My triangle does not. Use a ruler here to make sure everything is right. Bisect. You first have to close down this arc and join it because it will confuse you. It will confuse you. That's called the angle bisector. Then do the same here. To have an angle bisector. Close down this also. Oh, that's drawn in a wrong direction. My ruler is deceiving me a little here. I hope you have attained those bisectors, have you? Now, we do not want normally to assume a radius. Of course, we can assume that. Let us try to test every side, but it's better to construct also a radius. See that? By just constructing a perpendicular bisector to any side. That means you stand there, make arcs on this line. I'm constructing a radius, I'm not assuming. Make but it's going to be dotted. I hope the compass does not turn. Then here, then draw a dotted radius to touch the side there. Then that will be the radius of your circle. Yeah. Now you can now locate there and know that now my circle will now be touching here where your radius is. Then you can now rotate it, it will be neat there. You don't assume. You see, I have not been accurate. My things have been moving from place to what? Yes.
Is there by any chance that a circle may not touch all sides of the triangle?
It is there, like mine has not touched. Inaccuracies are due to that. The natural says as you shift, you see there are many things you do. Small errors, you move your you move your lines as you draw even this point where they met. Errors may arise. Yeah. Now let us go to Sakamu. Don't assume that radius construct it. Now let me go to circumscribing. Yeah, after circumscribing we can discuss some other skill. Circumscribing is to put a circle where? Outside. Let me, I think, do that. How do we attach? Let me draw a kind of the one that might be a bit bothering. How do we circumscribe, class? Some of you did it in primary. Yes, Grace.
You will have to create arcs using 2 points of the circle.
Like, I stand where?
You can stand at the down point,
Here,
the upper point,
and here.
and outside.
Outside here. That means I pull it a little. Make an arc here. Also stand here.
Yes.
Make an arc. Then,
You join.
even down this way.
Yeah.
And also, it means it's like you construct a perpendicular bisector on every line. Now this one will be perpendicular bisector. Then I go and look for another line. Is that right? I can use this one also. And shorten it a bit. Then an arc this way. Then this way. You can use another side, not so? Then have it here. And where they meet. Now I didn't tell you that when the circle is inside, that middle point, up we are seeing, when the circle is inside, that middle point is called the incenter. Whereas this one, when the circle is outside, it will be called the circumcenter. Incenter and circumcenter. Now here, we are going to, because our circle just passes through the tip, no need to check out the radius, because the tip is already a point where I'm very sure that I'm going to pass, not like where I'm inscribing. I hope you have noticed that. I hope now you actually this time. Okay, you have it actually this time. Yeah, that's very good. Now we are still finishing up the skills of geometry with putting polygons inside the circle. You get that right? And we can put a few, but not all. Yeah. But the more skills you have, the more you put. Constructing polygons inside a circle. And probable polygons we have a collateral triangle. We have hexagon. Hexagon is how many sides? Hexagon how many?
6 sides.
Okay. Square. Eight. Now, me, I will demonstrate here. I don't know. Let me make that my center and draw my circle, big circle. Yeah. Now we want to put a square inside. Construct perpendicular bisectors inside there through. Not so? The first thing I'm dealing with, a square inside there. I'm first putting my diameter from here, then construct a perpendicular bisector through this. Hope you are aware. How do you achieve that? You can just, not so? If we fix you the radius of a circle, make sure you can use a circle of radius 4. Now, that perpendicular bisector yeah. Now you have a square already. Don't you have a square? That means you are going to stand, you are going to just join the sides of a square. Here, join the sides of a square. Don't you have a square now? Yeah, you have a square. It means the sides are all equal. Now I'm going to equilateral triangle, and for it I'll even we shall progress up to. Now, before this is a square, but I can first have because a square, octagon is 8-sided, square is 4. That means I just need to use a square to get a hexagon. How? And that means, let me write about this square. But you reconstruct, not so? Reconstruct, and you reach the level of the perpendicular bisectors there where you've reached. I'm now on which shape? Octa what? Because octagon is 8-sided and a square is 4, meaning I can build an octagon from a square. Now I want to add more sides inside. I bisect. I divide this into 2. How? How will I bisect this? You can either draw arcs using this here, or you stand here. Of course, if you stand here, you'd still be bisecting, not so? Yeah. Or you draw arcs inside, any of your choice will work. You are bisected. And do the same. Do the same. Do the same for another, that means bisect it twice. Bisect twice. Now, I think you're seeing that angle bisector. The angle bisector is there, and also the angle bisector here. The octagon is finished. Now you join the sides to form your 8-sided figure. Join here, join here, here, and also here. Also, I think you see your octagon. Yeah, 8 sides are coming out. 8 sides are coming out. 8 sides are coming out. The skills are very, very good. Yeah. You can count those sides, not so? How many are they? Are they 8? Yeah. And it's a regular octa. Regular to mean all sides are what? Are equal. Now, we are going to the last one, equilateral triangle and the hexagon. Do you see how they are related? Because the triangle is 3-sided, the hexagon is 6. That means I just increase the sides. Equilateral triangle first. Yeah. Again, my compass adjusted to the radius that is commanded to you. That means when you say construct in a triangle or in a circle of given radius. Now, when you are there, Then also make a radius, finish up with the radius there. That means use the radius that we have given you. It is now when you are there, now let us make the last axis there without changing your radius. That's all. Have to stay this radius the same. Nope. Yeah, that means cut until you have finished cutting. Cut without changing the radius. Cut until you have finished what? Or make. I think you are way back here. Have you arrived back? My thing did not change. My thing has a bit, but you make X. You don't change the radius. It will come back here. Yeah. Now, just choose the 3 points at equal distances and make equilateral what? Which points are we choosing to make our equilateral triangle? At 3 equal points?
That first point.
This one?
Then the third one.
Then this one?
And then this.
Triangle is finished. That means your triangle is there. But it is equilateral. When you measure, all the sides will be equal. Yeah, there you are. Now that's right. Okay. If you want the hexagon, you join all the sides. Clear? Yeah. Join all, hexagon will have come out. Yeah, that ends construction skills. I hope you have got them by now. And it takes us to the last chapter called locus. Yeah. Locus. Definition and meaning of the locus. Meaning of locus. Describing locus. Describing and demonstrating locus. Demonstrating locus. Sketching and constructing locus. Yeah. Constructing locus. Yeah, right away we are on the locus. Our people are still okay in their heads. Now, if I started to move from here to a point ahead of me, maybe 2 meters, without changing my direction in any way, just one direction. You see, my footsteps would do. If I capture, assuming I stepped in white chalk and I started to move in class, that means you'll be able to locate where my footsteps have what? have stepped. Definition and the meaning of the locus. Now, we have said that when I start to move, you can, if my legs are dusted with chalk, you can know that he has passed here, passed there, because you see white color everywhere, not so? Now, when you join where I've passed, where my foot has stepped, you join with just join with a hand or a line and follow where it has gone. That what you have joined there creates kind of a travel path. It shows where I've been passing. That path there is what we are calling the what? Locus. Sure. If you have ever watched boys playing football and they shoot a ball in the air, somebody kicks the ball in air, how does it fly? In which form? Which form does it fly? If somebody kicked from here upwards, this is a boy, a man kicks the ball, and the ball goes in air. Finally, it has to come to the ground. Not so. If you happen to join where the ball passed, this now will create a curve, a locus, which is that appearance that is developed after joining the points where an object has passed. It's what we are calling the what? The locus. That means what could the locus be? So, yes.
The locus is a set of points.
Set of points. Exactly. A locus is a set of points that show the path of any object, and more so we add that following a certain rule, because we can say it is a semicircle or a circle, because we can say locus can be a circle with the condition that like if I said start running around a tree, then if this was the tree where it was standing and you started to run around a tree without changing your distance towards the tree or away from the tree, you'll be running a fixed distance called the what? The radius, if we happen. That means the condition is that you are moving without changing the distance from a fixed what? Point. Like if my locus is to be a straight line, then I should have moved, like if I consider myself moving at maybe 1 meter from the wall, but not changing it. Like I move 1 meter, but I'm not extending to the wall or away from, I will create a straight what? Line. That means you will define the locus as a set of points that represent the movement of an object following a certain rule. So, following a certain rule. Yeah, that's the meaning of a locus. Now, we want to give some scenarios where you can demonstrate a locus and even describe it. Do you have some situation? May I give you a situation of a ball kicked? Do you have some situations?
Yeah, like when you tie a goat.
Yes, when you tie a goat on a tree. Let me, I think, have I have this material as to show style, not when you tie a goat, Yes. Assuming you tie a goat on this peg here. Say what you're saying.
Then it tries to look for grass around, turning around the tree, but of the same distance.
The rope distance. It forms which locus? A circular locus. Okay, that means a rope will maintain the same radius from the peg to have a circular locus. Okay. Let me take this scenario that I have two. Let me have this demonstrated here. I have two walls. If you have two walls here and you walk in the middle, but you are walking the same distance away from this wall and away from this wall, going, which locus do we have? We form a straight line locus. Now it means locuses can be straight lines, curves in form of arcs, or circles. That's very, very correct. Hope that's mastered. Now, could I say that people can know what a locus is?
Yes.
How to describe it? Scenarios of demonstration. Then can we sketch a locus? That's our major point, sketching and constructing locus. Sketching and constructing the locus. Let me pick a scenario. A scenario here. A scenario of this locus. A scenario of this locus. I think we just give like two scenarios. Then people can go and work on their locuses, not so? Then you'll find more a locus. Let me give you, and we try to sketch out this one. It speaks that construct a locus. Are you writing that one? Construct a locus of a point equidistant from a fixed point. That's one scenario. Then part B, the other locus we shall have is construct a locus of a point equidistant from a given line. Then lastly, construct a locus of a point from a line segment of 6 centimeters. Now a line and a line segment are different. Do you recognize that? Yeah, a segment is a part of an ending line, an ending UN. Now when they say, what is the first scenario? Construct a locus of a point equidistant
From a fixed point.
from a fixed point. Yes, that a point is moving the same distance about a fixed point. How would that be? Which type of locus is that? Circular locus. That means we are constructing a circle of, though they didn't mention the distance, but you can fix, let the equidistant distance be 4 centimeters. That means we are simply drawing a circle showing that that point is moving. I think you can see 4 centimeters, 4 centimeters. If we join those points, it will be a circle around. Okay, that's 4 centimeters. And you label. Yeah, now that is a point that has moved the same distance around a fixed point. Now let us look at the part B. Part B, which locus is that if you move the same distance away from a line. You are moving the same distance. There is a line, like there is a line here, but you are moving the same distance away. You are moving. Which type?
Straight line.
A straight line law. That means that has a straight line. Which line is that? Will it just be straight? Well, they might be, because it's the same distance. How shall we ensure that the distance is the same from that line? Which type of construction are we applying there? Parallel construction, eh? Yeah. You told us how do we draw parallel there?
You create points.
Points.
And use those points.
And use those points. And create arcs. That's been very fantastic. Then we can have a parallel locus, not so? Yeah. Now the other part said what? Now this line never ends, therefore we don't have a fixed distance on it, not so? Yeah. Yeah. Now if it's a fixed line segment, now if like we say, how can something move 4 centimeters from this one? You can, 4 centimeters, you can, your legs can, not so. But since the line has an end, you'll have to rotate also around it. But in a 4 centimeter form, not so. Therefore, you'll have to move like this since the line is fixed. It's not just a line, but a segment. How are we achieving that? Make sure you have a line of 6 centimeters, 4. Yeah, a line segment of 4. You can call it AB or 4 centimeters. Then that equidistant distance, is it specified to you from that line?
No.
You can let it be 3 centimeters from there. Of course, you'll have to have your parallel line formed up and down, because we are going to rotate around, since the line has a limit. That's enough. Though there are 3, that's enough. Then down the same. But you'll have to move around, not so? But on the sides, you see that on the sides you'll develop a kind of a what? A semicircle locus on the sides, since it's a line segment. A line segment. Yeah, now the upper one is joined by a straight what? Line. That means that is inaccurate, but ensure you draw an accurate one to meet the tops of that. Then this must close up. Don't forget to label that also that movement was the same. Have you, which meters have you? 2 centimeters. Yeah. Can label everywhere too. Yeah. 2 centimeters. Then this one is also centimeters, then also centimeters. Yeah. That means finish, and we make the last comment on that topic. Then we have our activity of enter. Now we've gone through many things, and this is the end of geometric skills and construction plus the locus. We've gone through many skills of geometry, construction of perpendicular, bisectors, perpendiculars, angle bisectors, parallel lines, circles, arcs, polygons, triangles where we saw them, squares, so many skills. Angles, you know now every angle. Make sure you have those skills clear at your fingertips. And finally we're in the locus, where we've said it is just the path moved by an object, and it must have a certain rule of following. Now we have this activity of integration, and we shall meet in the next topic. That's topic 6. That will be sequences and patterns. Now, the activity of integration says here, before that, make sure you go and visit the new curriculum book for Senior 1 called Learner's Book, and also you can access the same information from this old curriculum book called the School Certificate Mathematics Book 1. You'll find there some concept to add to your head in the new curriculum. Now the situation of integration activity is saying, in a village there is an old man who wants to construct. In a village there is an old man who wants to construct a small house of wattle and mud. A small house of wattle. Wattle is W-A-T-T-L-E. Wattle. W-A-T-T-L-E. Wattle. And mud. Support. That means this will support him. A string. Sticks. A string. The support is string, sticks, panga, tape measure, and human resource. Resources, knowledge of horizontal and vertical lines, knowledge of horizontal and vertical lines, i.e. rows and columns, comma, knowledge of construction of geometric figures, knowledge of construction of geometric figures, task, geometric figures, task. The community asks you to accurately construct. The community asks you to accurately construct the foundation plan for this old man's house. The foundation plan for this old man's house. Paragraph. Explain how you have accurately constructed the foundation plan. Explain how you have accurately constructed the foundation plan. Discuss whether there are other ways of constructing an accurate foundation plan. Describe whether there are other ways of constructing an accurate foundation plan. Yeah, thank you. We meet in the next lesson.